Yes.
Okay, awesome. All right, recording started. Let's begin. So, what we are going to discuss today is what happens when you take a negative number and you multiply it by another negative number. We all know from school by this point that it's supposed to give you a positive number, but it is one of those things that makes you go like, doesn't make that much sense. That's how it was for me. And we already kind of talked about it at the beginning of class. There are some explanations given, like you take this and a this, that's okay to like remember that it's the case, but it doesn't really provide an explanation for why that is. Now, I want to just preface this thing by saying that people think that math should always make sense. And it should. But the problem is this. Math is done by people. And most people don't know that much about logic and like some basic things basic rules that math follows. My phone is buzzing a lot because Annie and Alex are chatting, I think, on Slack. Yeah, can you just move it away from the microphone so that it doesn't? Thanks. Yes, so what I'm basically saying is that a lot of things in math, especially, also in physics, when you learn as you get older, is that you always come from a place like, oh, this should make sense to me. But that's not always the case, because this new thing is kind of introducing a new concept in some way. So in the beginning, it's kind of supposed to not make that much sense. So yeah, with that out of the way, let's begin. So the type of proof or evidence that I want to show you why that is the case is by starting from a place that, starting from a statement that we know to be true with the math that we know so far. So let's take a simple example. Let's take the number 5. And let's multiply it by a positive number. 5 times 3. This we all know is 15. And I think we all get this. It's very intuitive. And if you wanted to write it out in a different way, you could say 5 times 3 is the same thing as 5 plus 5 plus 5. This is going from a higher level concept of multiplication to addition. Exact same statement here. And then this we, of course, know to be 15. Simple enough. All right. Let's, from that, go to something that is a little bit more advanced, you can say. So let's take, again, 5 and multiply it by negative 3. And I'm going to put it in parentheses just because it makes it a little bit better written down. It looks a little bit better. So now I'm going to say, well, what is this? Let's just say that this is something that we don't know yet. So let's do something with the statement that we have on the left side. So what if we forget about the exact statement that we have on the left side and come up with something a little bit different? So what if we took 5 and we said, let's multiply it by this thing. We'll say 3 plus minus 3. Now, what is that? Well, let's go back to maybe something that you guys remembered from when you were in like 1st or 2nd grade. You probably had this number line, right? And then you start at 0, and then you start counting. So let's say that we start from 1, 2, 3. So that's what we have here. So we start at 3, and then we go minus 3 on this end, right? So this basically becomes 3 minus 3. We're taking 3 and then we're adding it to the opposite of 3. So then that means we go here and then we go back. So what is this going to be? Well, this is 3 minus 3 is 0, of course. Any number minus that same number is 0. So that means that this whole term is going to be 0. That means that 5 times this term is also going to be 0, right? Because any number times 0 is going to be 0. So we know that to be 0. All right. Okay, cool. One more thing that we know from early in our math careers is something that you might not know the name of. It's called the distributive property. And all it does is that when you have a parentheses like this, if you want to write out the entire thing, what do? Well, you multiply this number, and then you use whatever is here, and then you multiply this number with that number, and then you write it out like this. You guys are all familiar with this? Yes?
Yes.
Yeah? Okay. Yeah. Please let me know, guys. Stop me if there's anything that is not making sense so far. So we then do that, 5 times 3. That's the first one. And then we do plus, and then we do 5 times negative 3, which I'm going to write like this, and I'm going to do a little dot here, which is the Norwegian way of writing this. Some of you, if you're doing like IB or something like that, you might be using this exact same thing, of course. So, all right, so now we know that this is definitely equal to 0 because we just figured it out this way. The right side is the same. Okay. So what is this going to be? Well, 5 times 3, that's something that we've done here already, right? That's 15. And then we have this thing. All right. Now, this is a good point at which we have to understand that in math, if you are trying to show something that you are in doubt of, or there is a statement that you want to show this statement is true, for example, that a negative times a negative is a positive, for example, then you're using already established truths, like, for example, this one. We're using this fact here. Now, what is important is that whenever you're doing math, past facts that have been established are unbreakable. So you cannot say that if you only did this math on Mars, then it would work differently. No. What's been proven has been proven. Math must be consistent. That's very important, that anything that we're showing here cannot go against something that we've shown here that we know to be true. So knowing that, what then must this term be equal to for this entire equation to be valid or true? And I want one of you guys to answer this. What must this term be equal to? Which number?
Just negative 15.
Negative 15, yes. I saw that there was someone on the chat. Robin, you were, okay. Did you mean that? Did you mean negative 15? Okay, cool. Yeah. So what you were probably saying that this has to be equal to 0, right? That as Tom said, it has to be negative 15. Are we all okay with that? Anyone has any objections to that? We're all good? All we're doing is that we're saying that this must be the case based on everything else that we have. This is kind of like a fill in the blank type of thing, where there's only one answer. Okay. Robin, you're saying yes and no. Please let me know what your thoughts are. Why are you saying add no? Yeah, and yes is correct. Okay, cool. All right, so that then must mean that 15 minus 15 is 0, of course. This part is obvious. We already figured that out. But this means that 5 times negative 3 must be negative 15. Now, Did we just show that a negative number times a negative number is a positive number? Not yet. We're building up to it. What we did show that based on the things that we know already of multiplying just two positive numbers together, if you now go one step further of having a negative number as one of the numbers and the first number is positive, then the result is always a negative number here. Now, did I really prove it for all numbers? Not really, because I'm using specific numbers. So I kind of just proved it for 5 and 3. But if you just replace 5 and 3 with A and B, for example, and you say A and B are integers, then you can write a proof that says that this is going to apply for all numbers. All right. So Robin says something in the chat, and no, I don't have anything to add. Okay. If you do, please just unmute yourself and just jump right in. Okay, so we're all good at this point, right? Everyone is okay? Okay, so with that said, let me now start writing on this part. So I'm going to just erase this. Okay, now I think you know where this thing is going. I'm going to go one step further, and I'm going to say this. -2 times, right, times -6. Okay, now you might be thinking, is it supposed to be written this way? This is kind of looking a little bit weird. Well, you could write it this way, it's totally fine, but you can also write it this way. If you like to have parentheses outside of negative numbers, which I kind of do, then you can also do it this way. But it's really just exactly the same thing. So this is the point at which we are taking a negative number and multiplying it by another negative number. What is this going to be? We don't know. We don't know yet. So let's say question mark. Now, again, so let's kind of go through the same process that we took through, I took you through last time. So we'll start with -2. And then I'm going to say, multiply that by not -6, but 6 plus -6. And of course, I mean, 6 minus 6, 0, same thing as before. So that definitely is going to be equal to 0, right? Because this is going to be 0, this term. Multiply any number by 0 equals 0. Same exact thing as before. Okay, so then let's go one step further. Let's now use the distributive property as we did before. This multiplied by plus and then this thing. So let's do now 2 times 6, or rather -2 times 6 plus, then we'll do a -2 times a -6, like this. And I'm going to put that all in a big parentheses. There's going to be a lot of parentheses now. Hopefully that's not too confusing, but I'm just kind of grouping it up so that it's easier to work with. Equals 0. Now, we already established from our last fact that we kind of proved that a negative number times a positive number is always going to be a negative number. So let's just go ahead here and say -12. Now here, I'm just going to write this as it is because this, I don't know what this is going to be. And then I'm going to say 0. Now again, what have I just shown now? For the world to make sense, for math to be consistent, which is something we always want, this term must equal which number? Which number must this entire thing equal? You can either say it out loud or write it in the chat. So -12 plus what number is equal to 0? 12. Correct. So this thing here must equal +12. So that means then, let's go like this. Must equal +12. And there you go. Proof is done. So did it magically just make sense to you now? Why a negative number times a negative number is a positive number? If it did, I want to hear it. Okay.
Quite.
Yeah. Not quite. Yes.
I can see how though.
Mm-hmm. Exactly right, Tom. So this is exactly why I wanted to do it this way, because just because you prove something, even if you're like doing a higher level math exam at university and you prove something, it's not like your brain goes like, yeah, that makes intuitive sense to me now. That's just part of my like brain system, and like a new set of neurons just magically appeared and it makes sense to me, like 1 + 1 is equal to 2. It doesn't work like that. But now you have, and that's why you see that math, even though you can prove it, like humans aren't really very good at math, like, to put it mildly, because if we were very logical beings, math would not be the subject that most people in school would say that I hate. It would be like everyone loved math because it would be so easy. It would be logical all the time. That's, I think, one of the reasons why math is one of the most hated subjects. So yeah, there you go. This is a proof for why a negative number times a negative number is a positive number. If you want, you can go through these examples by yourself and kind of prove it by yourself. But yeah. Mm. So any questions to this that you guys have? What was it, at least kind of making sense from one step to another step? There were no step where you felt like, oh, you did something that is not allowed or anything like that?
No, I'm just looking back over it to like reinterpret it.
Mm-hmm. Let me just. There we go. Let's see here. Yeah, so let me just.